Very cool that it stopped working. But like, whenever I go to write now, you see how it skips all the time? And there's literally no way that they're able to figure out what it is. Like, I've been on the phone with Smart Notebook for like 20, I'll say conservatively 10 hours. The other thing is, like, I even had to go and find like an old computer. This actually works, ironically, in spite of the fact that the new one doesn't. But as you can see, this laptop is very, that's what, try holding it. Would you say this is heavy or light? Light? I would duck if it was coming at me. If someone ever tries to do any harm in this building, if you clock them over the head with one of these computers, you'll kill them right away. I mean, right away. These things are husky. But nothing works. And until we can find something that works, I'll caution you now, I hate this more than anything, but I have to be one of the people who, I have to actually learn how to do this. There's some sort of pen. Yeah, this is supposed to be able to write now here. But that means, A, I'm looking at this instead of you. And I have to write on this board, which has nothing on it, so I don't know if I'm writing in the right spot. If I swear under my breath, you have my apologies. If we screw things up and the handwriting's not neat, you have my apologies. It's literally the point where we were at Costco, and I was ready to spend $800 on my own computer to make it so I could write on the board, but then they win. So we'll do our best until we can get one. Maybe we'll even have to GoFundMe a nice computer that we can actually write on in here and have legible notes for you. Now, we left off, are these the ones your class got through? Is that right? Okay, so we're going to keep going. In all honesty, this third one here is probably the most difficult out of all of them. We're going to save that one to the very end, even though apparently, according to the morning group, they said that they knew how to do them and were pretty good with it. So, first one that we'll go through and look at now is this one down at the bottom. And we want to call it a factor by grouping. It's the fifth one down. We want to call it a factor by grouping, but that's sort of a misnomer or a bad name for it. You're really good at doing a GCF one time. And if you can do it once, I bet you can do it 3 times. Take a look at the example that you're given with 4 terms here. So this is called, if it's got more than 3 terms, we generally just refer to it as a polynomial. We've got this generic polynomial over here. And that polynomial has 4 terms, none of which can be combined. So we can't shrink it down to less terms. Is there a GCF for all 4? Yes or no? Take a look at those 4 terms. Is there something you could divide out from every one of them besides 1? You know, 1 before. No. So what you have to instead do is ask yourself, can I get my GCF by going through and looking at it as parts of an equation? So in the beginning here, we know all 4 don't have a GCF, but what about maybe the first 2 and the last 2? Look at the first 2. Is there a GCF there? And the answer is yes. What can you take out from those first 2? Hands up, please, when you can tell me. What you can divide out or undistribute from those first 2. Go ahead. You can take out a y. And when you undistribute that, it leaves you with the quantity of, when we say stuff in parentheses, we denote that by saying the quantity of x plus 2. Look at the second set now, the ones in green, terms 3 and 4. Is there a GCF there? And the answer should be yes. We can take out a 3. And when you take out a 3, you're left with an x plus 2. As of right now, though, all you've done is rewritten what you currently had to begin with. That's it. You've done a GCF, by the way, so far. How many times? Twice. The whole goal of factoring is to list things out as a series of products or a bunch of multiplications done together. Because if you multiply anything by 0, you can make it, if you multiply anything by 0, the total value is 0. So you can find what numbers will zero out your expression quickly. We have a binomial, 2 terms still, not enough multiplication, there's still a plus there. But you're not done. Look at what's in blue. It might be a little bit awkward, but there is a greatest common factor there. Something that you can factor out from the left and right sides of this great big giant awkward binomial. Hands up, please, if you can tell me what's common to the left and right sides of our new binomial that you can factor out. What are you left with when you undistribute out that x plus 2? There you go. Just do whatever the operations are telling you. That's the process. It's a triple GCF. That's it. If you can do that and follow it along, that will be on your final exam, and we'll do it like 45 times during the year. There's not an excuse that you should ever get one of these wrong. It's great if you get it on day 1. We'll be doing it from now until day 135. Take a look now at this grouping here. We've got 4 terms. This is a cubic expression. You know it's cubic because it's raised to the 3rd power. Quadratics are raised to the 2nd. Looking at what's there, there's not a GCF for the first 4 terms. Now let's try looking at it in halves. Look at the first 2. Hands up, please, if you can tell me if there's a GCF, and if so, what it is. We've got 1, 2, 3, 4, 5. What would you like to say? Now, we can take out a 2x squared from both. Hands up, please, when you can tell me what I'm left with when I undistribute out a 2x squared. Now, this second part is the part where you've got to remember your objective. Our goal is to try to get a GCF for everything. You still got 2 terms at the end. There's 2 possible GCFs you can pick for terms 3 and 4. Hands up if you can tell me what those 2 possibilities could be. I don't need the one you're picking. Just tell me what 2 possible ones could you take out if you're looking at terms 3 and 4 in here. -1 is one of them. Or, what else could you take out? +1. Only one of those, though, will be advantageous to us or help you progress through the problem. Which GCF would you want to take out from 3 and 4, and why? Go ahead.
-1.
Why?
+2x and +1.
Careful. What's the point? Why would you take out a -1 instead of a +1? You gave me what it would factor to correctly. Why do we want the negative, though? You need to create the GCF again. So look to make that happen. And then go from there. And by the way, at this point, now you've established the GCF. The GCF is 2x plus 1, and you're left with 2x squared minus 1. It always gets a little bit frustrating because some of our colleagues at times, when they're explaining this to people, will actually call it, like instead of calling it factor by grouping, they'll actually call it something like magic factoring or something like that. There's no magic in that. Okay, there's no wizards or anything like that. Like, it's numbers and division. Should be pretty good with that. This next one, I'll tell you, I don't think that this is the hardest, but it's the most difficult. This is the only factor pattern that is new for you this year, as far as I know. Maybe you did it before if they really pushed it over its stride. When we're looking at this, these terms here, this is what the generic factor pattern that we're going to be applying is. These terms are cubes. You guys are really good at identifying perfect squares. You do it almost automatically. Hands up if you can tell me any perfect square number. Hands up, please, you can tell me any perfect. Hands up if you can tell me any perfect square number. We all should be dislocating our shoulders. 64 is. 25 is. 9. 16. 4. 9. We can get 36. You can go 144, 121, the whole deal. You're responsible for knowing that we're under the assumption that you're wrong. The cubes, though, you probably don't know. And we're going to list them out down below. The perfect cube numbers that we need to make sure we're looking for are going to be numbers like 1. Oh, here we go. 1. Not 4, but 8. Not 9, but hands up when you can give me my next one. 27. Who can give me the one after that? We've got 1, 8, 27. That means we did 1, 2, and 3 and cubed them. What's 4 cubed? You can use your calculators if you need it. 64. Now, 5 cubed is? 6 cubed is? Isn't it 216?
Yeah.
216, then 7 is what? 343? Ugh. And so on. So that continues on. Now, as we're looking at it, another thing that's a little bit awkward in the beginning is how to apply the pattern. So I'm either going to tell you, you've got to sort of build the house before you move into it. Look at that one that we have up above. That's a sum of perfect cubes. Let's start off with this. What's the cube root of the left side, or what times itself 3 times gives me 27m to the third? Hands up, please, when you can tell me. We'll wait for 5. 1, 2, 3. What do you want to say? 3m, and our cube root of 8 is a 2. So I go in over here, and right above both of them, real small but noticeable, I would go in and write out this would be a 3m here, and a 2 here. Now, I just write out what those perfect cubes are with the A and the B are. Now, you're going to need to list out on your paper space for a binomial factor and a trinomial factor. A binomial's got 2 terms, a trinomial's got 3. So what I need you to do is give out space for a binomial factor to fit inside parentheses, and then a trinomial, which is 3 terms. The sign here is a plus, so that means going across, the signs that we fill in are going to look like this. Let me see if I can get this here. So there's space for a binomial, and here is space for a trinomial. Since that's a plus, your signs going across will be plus, minus, plus. So it goes plus here, minus here, and plus here. So there's space now for 2 terms in the binomial, 3 terms in the trinomial. The binomial, it tells you to the left, take the A plus the B, or the left plus the right. Who wants to guess what the binomial factor is, or just apply whatever that pattern is? We got 1 of us, 2, 3, 4 of us. Go ahead. There you go. This would be just the left plus the right, or A plus B. So that's 3m plus 2. Now, the trinomial says take the A and square it, then list out the A times the B, and then the B squared. And boy, don't be discouraged if you screw up the A squared. Almost all of you screw it up the first time. Who's got a guess, though? Because there's a little area that we could go wrong on it. What do we think our A squared would be? What did you remember to do that most will forget? The 3 needs to be squared also. When you're doing it, it's not just the variable that gets squared. So this now is what? 9m squared? Now we need to take the A times the B. So that would be a positive 6m, and you know the sign from what we listed out before. I'm deleting this so we can go through and just show what the actual answers are. From here, we've got this. And now what are we going to end with at the end to finish off our trinomial? Go ahead. Which is? Nope. We're close. Oh, wait, you're right. Sorry, for that one you are correct. I'm sorry. It should just be a positive 4 at the end. I'm sorry. I was getting ahead of myself. Questions on that? Binomial, trinomial. The signs going across. If it's a plus, go plus, minus, plus. If it's a minus, they go minus, plus, plus. That's it. Go through right now. Try the one that's the sum of, the difference to the right. Try that one out. It doesn't work. That's why God invented erasers. It doesn't change it. Oh, well, you can see the signs from up there too. Copy down those signs also. Give it a try. Who can tell me what the signs will be going across? You list out your binomial and your trinomial. What are the three signs you've got to remember going across going to be? There you go. It's going to be minus, plus, plus. Who wants to take a guess as to what our binomial factor is going to be? We've got 1, 2, 3, 4, 5. There you go. Remember, the cube root of the left is an n. The cube root of the right is a 4. So that's our binomial. Who wants to give a guess as to what the trinomial or three-term factor would be?
N squared plus 4 plus 16.
Remember your signs going across. If you need to see it, the signs going across, if it's plus, they go plus, minus, plus. And if it's minus, they go minus, plus, plus. You might want to throw that down there. It's for you to go through and know. We've got one last one that we haven't dealt with, right? We still didn't do that 2m squared one. So when you're doing out a problem like that, I guess from what I understand, or at least from what I was told by the first group, if you have this over at Spry, they showed you, what was it, 2, and I'll do this one. I'm doing a different one. Now, if I were to give you this, you guys already apparently know this, that when you go through and you've got two binomials like x plus 5 times x minus 6, when you multiply those together, you multiply the first terms together, you do a FOIL, not some box thing. Did they show you, did they have you do it with a rectangle or no? Yes? Okay, I don't ever use that. I don't know if they showed you, FOIL, but we only do that one where we do first, outer, inner, last. So our first terms will give us x squared. Our outside ones, which are these two here, these here, okay, those would give you negative 6x. These give you 5x, and then you end with a negative 30. So what part of this caused us to get x squared minus x minus 30? Well, where did the x squared come from? It came from those x's in front. Why did we have, or why is there a 30 here? Because it's the last ones, right? Now, why is there a 1 here, or negative 1? That's what you get from the outside inside part, okay? Now, if we're factoring this down, you're going to want to list out 2 parentheses to start and 2 binomials. Now, as you do it out, what goes in those beginning spots? You've only got one option. How can I get a 2m squared? 2m and m. There's only one way. 2m squared. Some of us start with this. We get it. I know some of you go, well, I could take 4 and divide it by 2 or multiply it by a half. We get that, okay? Get over it. We need you to think of integers when we're doing factoring. You've got a 2m squared in the beginning. The only way to get it is a 2m and an m. Now, I need a positive 3 at the end. However, there's 2 ways I could get a positive 3. Hands, and even though 3 is prime. Hands up if you can tell me what's one set of candidates or one pair that I could throw in at the end. I don't care about the order. What are 2 numbers that I could throw in to finish off this that could go there? Not do go there, that could go there. What numbers could I place in these spots? Hands up, please, when you can tell me. What's one possibility? Negative 1 and negative 3. How else or what else could go in that spot to give me the positive 3 at the end that I want? Positive 1 and positive 3. Now, think about it for a minute. You've got 2 choices. Which of the choices do you think is the smarter choice to make? Hands up, please, if you can tell me which of those pairs, we want to do +1, +3, or -1, -3, which pair kind of makes more sense? Or you go, oh, I've got it. I'd say the negatives. Why the negatives? Because you've got a -7n. Now, furthermore, I can see it kind of clear what needs to go where. That's because I've done it about 25 years. You are on maybe example 3. I'm not expecting you to get it right the first time. But understand, if you want to get it right and get quick at it, you've got to go through and sort of have some attempts that aren't going to work. I'm going to say this. We already ruled out 1 and 3. Let's see why I couldn't put a +1 and a +3 here. Watch what happens when I do this out. You're going to erase it, so don't worry. You don't need this on your paper. This can't be it, because as I'm doing it, I say, all right, I got 2m squared. Then I get plus 6m plus 1m, and then plus 3. Now that's really close to what I need. Why is it really close? Hands up, please, if you can tell me. Even though, by the way, you're going to learn this. Make the mistake, but get over it. I cannot stand people who are afraid to make the error. Like there's some of us who won't write it down because you're, oh my gosh, then I'll have to erase it. The paper won't be perfect and pristine. Life is not perfect and pristine. You're going to make mistakes. Get over it. Why am I so close from the result I just got? So they're in the right spot, I think. What's the only thing I would want to change? Hands up, please, if you can tell me. What modification do we need to make here? Let's change them both into negative and then watch what happens. We'll change this and this. So we've got, and we said -1 here and -3 here. So as that gets done, you've got 2m squared. The outside terms give you -6m. The inside terms give you -m. And then the last terms give you +3. Did that work? Yes. And by the way, if we didn't get a 7 from doing it, let's say you got a 5, then the numbers should change. If the signs were off, that's it. Now, we're going to have tries. I don't know, did they show? Apparently this is how they showed it last time as well, or no? Yes? Ish? But regardless, we need to be able to do it. So we're over to here now. What's good about this example that you're looking at? You tell me, why is this good, at least in the beginning? How is this going to start off, or what's good? And by the way, on your paper, make the 2 sets of binomials. Why is this a good one? I mean, we could make it a lot worse. A lot worse. So what do you need in those first positions? 2m and an m, so throw that in. Now, we need a -3 at the end. What numbers multiply to give us -3? Or what are our candidates to go in those end positions? A 1 and a 3 with mixed signs. -1 +3 or -3 +1. You've got to pick, and by the way, we don't know where they go either. Only way to make sure you've got it is to go through, take a guess, check to see if it works. So go through and do it right now. Plug something in there. If it doesn't work, turn your pencil over and erase it. We'll wait for 7 of us who can tell us what 2 binomials this will factor down into it. I've got 1, 2, 3, 4, 5, 6. What do you want to say?
2m plus 1 and m -3.
Now, to see if this works, I would go in and say, all right, first terms give me 2m squared, that works. The outside terms give me -6m, and the inside terms give me +1m. I'm not concerned about the end. I picked 1 and 3 for a reason. They work. Does that arrangement give me the -5 I was looking for? Yes. Am I expecting you to get them right the first time, every time? No. But the only way, some of you get paralyzed by this fear of taking the next step. You can do it. There's only so many ways you can add, subtract, multiply, or divide. I can't give you much that we haven't even done already. Patterns might be new, but the algebra really shouldn't be. Now, does this mean as of now you've got all 6 of them done? Yes or no? Great. Now, take those, keep them to the side, use it to help out with homework. Use it to help out when you're going through and doing your notes, whatever it is that we need to get done. Use it as a check down list. And if you're doing it, say, well, what does it look like? Go and look at those patterns. See, oh, this one's closed but not quite, etc. And I know how to do those. Your assessment tomorrow will be on factoring as well. We got some here. Oh, we need to go to our notes. So switch over, please, to that great big giant blue packet. Should look like this. Go through and okay. Go through right now and let's have you do. See, for example, 1. Go through right now, please, and do 1A, and we'll also have you do 2D. So going right now, please, we'll have you do 1A and 2D. It's on the first page. All right. Page numbers at the top. You need to use your calculator, do it. Whatever it takes, we need you to get it right. Did we do that one right for D? Is that right? Okay. Do we have questions on either of those? What type of factoring were both of those? Yeah, just a GCF. The next ones we'll try. Well, this is slightly different than what you did before, but look at example 3. Kind of go out of our way to make it easy to see, but maybe you won't. Hands up, please, if you can tell me. What can you do in 3? What would we do to start out 3? In the back, what do you want to say? Yeah, we've got a GCF there of x minus 5. So we'll go through and we're going to take out an x minus 5. Now, I'm going to leave in parentheses everything that comes after it, that's left after you divide it out. Who can tell me what we would have left? Don't simplify, just tell me what remains after you undistribute the x minus 5. Who can help us out with what we would have left? Got 1, 2 of us. Look at what's there. Undistribute, pull out the x minus 5, and how much would we have? 1, 2, 3, 4 of us. 5? Don't be afraid, it doesn't bite. In the back, what would you say? So let's list that out. You've got an x plus 6 on the left side, and then there's a plus, and then 2x plus 5. We don't need to distribute anything out to it, so that's okay there. I'm still not done, though, because as I'm doing this, I go, well, wait a minute, this is x minus 5. We can keep going inside these parentheses. And this leaves us with what? 3x plus 11? Was that too much? Little bit harder? Maybe. Maybe. I don't know. When we divide this out and that out, that's what you're left with. X plus 6 plus that. Let's have you do this. We want you to see the other one. Go in now, please, and try out. Give B and D a try on there, please, in that next example. One thing, too, that we'll start having you do while you're, I hate calling on particularly random volunteer, well, we'll say random, people who volunteer to give answers just in general. If you had an older brother or sister that had me, maybe they complained about it too. But I just go through and call on you by like a random deck of cards. Problem is, I copied over all of your names, but some people, like if there's like a Daniel and you go by Dan or something like that, I need to know what you actually like to be called as opposed to what the computer system has you in as. So after this set, I'm going to give you some examples, but I'll call you guys up one at a time. You'll see your names up here. If it looks right, just tell me my name is Bob, and that's fine. Or my name's Bob and you spelled it wrong. Or my name is Robert and I go by Bob. Let me know what you'd like to be called. We'll be calling you up after we get this set done. So go through and do B and D, and then we'll call you up so you can take a look at your name and let me know if I've got it right. Take a look at that first one. Do we have any questions on B? The GCF that you could take out, what do both sides of that great big giant awkward binomial share? They both have a, what is it, m plus n being squared. And then when you take that out, it leaves you with z squared plus x squared. Do we have questions on that one? How about the next one? Hopefully you saw that p minus 5 and could take that factor out. This is where it's going to get a little bit weird, though. Look at all of this that's left over in here. What still needs to get done? This is where you're going to make the mistake. You actually are very good at factoring. The problem is that we're not that great at algebra. Yeah, what do you want to say? Yeah, we've got to go through and subtract both of those. So if you want to list it out, I'd say p minus 5, and then go through. Now, there's a couple of ways you can do this. Some of you are rote learners and need to show that distribution. If you need to, show it. You're the one who benefits. Some people can go through and see what's going on and say, well, this is p minus 3p. That would give me negative 2p. And then I've got what's 2 minus 4. Last time I checked, 2 minus 4 was negative 2. Now, none of us should walk away right now. It's very tempting to, and you want to congratulate yourself because you did something difficult, and if you need to, great. You're not done, though. Who can see why we would not? This would get you 3 out of 4 points, but it will not get you full credit if the prompt was to fully factor. We've got 3, 4 of us who see why this shouldn't be our final answer, 4 or 5 of us. Absolutely correct. There's another GCF. So I'm going to take out a negative 2 that p minus 5 stays the same, and this second factor is going to be, there you go. Do we have questions on that? Now, we're going to get to some real easy factor by groupings, hopefully easy. Go in right now, please. I want you to, on your own, give example 5 a try. Go through right now on your own and do out example 5. And can we get the first group to come up, first row over on the side there? Can you guys come on over? Okay, this is you guys. Yeah, there's two. What's your name? Are you Mason? Okay, thank you.
I'm Alexander, and I go by Alex.
Okay, thank you.
I'm Gavin. I just go by
Gavin,
Gavin.
okay.
Samantha, Sam.
Sam, okay.
What is it back there?
Yep, we'll just take the pass.
Isabella, I go by Isabella.
Okay, thank you. Patrick, and you go by Patrick?
Yeah.
Okay, thank you. All right, guys, take a look at that first one. Is there a GCF for all 4 terms, yes or no? No? Hands up, please, when you can tell me what you wanted to do in order to get this question factored. We'll wait for 7 of us. So far, we've got 4, 5 of us right away, 6. What would you like to do? So when I take an A out from the first 2, what am I left with? X minus Y. Now from the second group, I'm going to take out a positive B, so those binomials at the end will match each other, so this becomes an X minus Y. Put it together, you've got X minus Y is your GCF, A plus B is what's left over. Do we have questions on that? Okay. Take a look at... Go through, please, and try out 7 right now on your own. And while they're doing that, row 2, can you guys come on up, please?
Emily.
Okay. Is that right?
Yeah, that's right.
All right, thank you.
Lily.
Yes.
Lily.
Willie? Okay.
Devin.
Go by Devin, is that right? Okay. Evan? There you go. Okay. Phil? Okay. Thank you.
Sarah.
Sarah? Go by Sarah?
Yeah.
All right. Andrew. Oh, and I got to add you in here, sorry. So it's, and what's your last name, Andrew?
Geyser, G-E-I, that's the art.
Okay. All right. Perfect. Thank you. All right. Take a look at example 7. And as we go through and do out 7, I hope this one is easy for us. I think it would be, but what can we take out from the first 2? Hands up, please, when you can tell me that. What can we factor out? Go ahead. And what's left after you take that 6x out? Now comes the part where it's a little bit awkward, maybe. I don't know how good we're going to be at this second part. What do we factor out from the stuff on the right? We got 1 person, 2, 3, 4, 5 of us. I'm going to say, well, I can't put enough in there. A positive 1. So I'm going to go in, put a plus 1 there, and that leaves me with a plus 2b, which means I now have factors of 6x plus 1, and there you go. Questions on it? Bless you. Now, one thing that's going to be very interesting, these example 8s show up on the REAG as free response questions for a reason. As it stands right now, this arrangement does not factor by grouping. You cannot get a common GCF if the terms are in this order. However, are you constrained to putting the terms in that order? No. So, understand, as it is, you can't do it. There's more than one way that will work. Rearrange the terms and get this to factor down by grouping. Go through and do that on your own right now. Remember, you're looking to make it such that, and by the way, The way to see if your arrangement works isn't to stare at it, it's to actually just do what we did on the left. And if it works out, great. If not, you erase it and we try another order. We get row 3 to come on up. Okay, you go by Matthew or Matt?
Matthew.
Matthew, okay. Mason, you go by Mason. Okay, thank you.
Alex.
Alex, all right, thank you.
Luke Ensley.
Okay, go by Luke.
Yeah. Go by Ryan.
Ryan, okay.
Jason.
Jason, hang on a second. Do I have you on? Oh, I do, okay. Yes.
Sam.
You go by Sam?
Yeah.
Okay, thank you. Now, who got an arrangement? How did we choose to reorder this? Hands up, please. Who's got a way that they think is going to lead us to getting something that we could have that could factor down? Got one person who tried a different arrangement. Really? Really, I think any of the other ones are.
6ax plus a plus 12bx plus 2b.
Hang on one second. You're saying this one here, what'd you give it out as?
6ax.
Oh, for this, for 8.
Okay.
Sorry. If that was a confusion, 8 needs rearrangement. And then you had minus 10 and plus 5p squared. Okay. Now, I feel like that arrangement's got a really good shot at working. You might have done it in a little bit of a different way. We're still going to get to the same answer if our algebra is right. Look at those two on the left. In this arrangement, I can factor out a q squared from both. So that leaves us with what? P squared minus 2. Now look at the second two. This will be where it's awkward. Hands up when you can tell me, what am I taking out from the second two? Remember, we want these to match. Positive 5, which means I would have negative 2 plus p squared. Now, even though it doesn't look like it, do you have a GCF there? Yeah, it's p squared minus 2. So you'd go p squared minus 2, and then, there we go. How many of us got to that point? Not bad, guys. Not bad. I hope we can. Let's see what else we got. Now, as far as your homework tonight, here's what I advise. I'd say, we'll have some people freak out. 2 through 20 on here, I'd say go through and try the evens. Okay? 2 through 20, I'd say try the evens tonight when you get home. I think there's, actually, you know what? No. Let's change it up. Those ones are kind of really easy. Let's try this. Let's have you do 2 through 12. And where's some good ones? Maybe I didn't get any. You know what? I'll let it go. Do the 2 through 20. I think most of these, though, I don't know how many are grouping. Some might be just GCF. Maybe 19 and 20 are grouping. I think they are. But if they're just a GCF, we'll have to get over it. Yeah, just do the evens. I mean, you need to do a sampling of it. Now, here's one thing that does get frustrating. Invariably, we start with this. Some of you, when you're doing it, you go, where's the answer key? Now, sometimes I'll give you some. Sometimes we won't. But here's how you can always go through. Oh, wait a minute. Sorry. Here's how you can always go through and get an answer key. If you go to, there's a website. Who here has heard of Wolfram Alpha before or used it? One person? Oh my God. This might be your saving. This is the best math website that's ever existed, ever. If you want, give me, what does it say for, what's example 2 for you, your first one? So type in 15 times R. So use the times button, minus 45. And what did I want it to do? Factor, right? So then you hit enter. And guess what it gives you? It factors it down. You can always check your answers on that. It's called wolframalpha.com. It's not that tough to remember. You can go back and watch the end of the video if you want. It's kind of an easy way to go through and check it. All you have to do is say, factor this. And if you need it to swear, you can do a caret 2, whatever it is. It's a great, great help. If you have questions, come and ask. Now, and by the way, when you do your homework tonight, will this be helpful? Maybe. But here's the other thing. Make sure you know how to do all of them. And I'll tell you right now, there just might be a factor by grouping on your assessment tomorrow. So make sure you know how to go through and do it. All right? You can slide those calcs over on the side. And I think your homework really tonight is just get those questions. Oh, and by the way, we said it before. What's going to happen next time we have class tomorrow? Yeah, it's that other person. Because this smartboard is such garbage, we may be going to another room. They don't want the other person to see how bad our smartboard is. So we may have to go. You'll see a note. It will be next door or something like that. You get the same seats-ish that you have. Thank you very much. We'll see you all tomorrow.
Thank you. Have a good day.
You too. You too, guys. Have a good one. Like that? Yeah. You want? Okay. Actually, to make sure the copies open to another one, you can be the same as the other one, and I'll even try to take a higher one tomorrow. Okay? Yep. We'll see you later, guys.
Yeah.
You're welcome. Yes.
Should I get on the math Excel or just do that?
So I will have you sign up for it next time that we meet. Okay? Don't worry about. We'll do the math Excel. Actually, we have to do it as a group. The only thing with the math Excel is we had issues with the codes. I'm going to try to do it next time we have class, and some person's giving a sample lesson or whatever, but it is what it is. So at the end, after that person's done, I'm going to go over how to sign up for the Math Excel, but I need to make sure the code's going to work, so we'll do it together as a group. I don't want you to do it alone. Okay? Other than that, I think you're all caught up. Did you sign up for classroom and everything?
Oh, yeah.
Okay. You should be good. Thank you. Guys, grab your calcs and that factoring assessment on the side. Thank you.
You have one of my boys from last year.
Oh, no, I had him before.
Yeah, study. Got you there.
I knew his name because I saw
Oh, yeah.
the brother who was a senior, and I was like, oh, like I know who you are. But I never had like any issues with the brother.
Geo enriched?
Yeah.
So yeah, you would.
So he doesn't. Yeah.
Okay.
No, I assume that if he's anything like the older one. Oh, worse?
Oh.
Great. Oh, that makes it even better. And what periods do you teach at Thomas? First and second? Okay. We may. Oh. Yeah. Guys, go through. Please get your assessment done, and we'll have you sign into your calculators in just a minute. First and second, that's it?
Yep.
Okay. So, I mean, what? I guess I would. We may need to use your room first tomorrow. Is your smartboard working?
Yeah. I mean, for the alignment's not perfect, so you're just gonna have to have some guesswork a couple inches away from where it's supposed to hit the board.
Like what you recalibrated it?
I recalibrated it.
Okay.
It's not terrible.
As long as, but it's functional. Like if because we need space for that person to do their sample. What periods do you teach at Schrader?
5, 6, 7.
And you teach all three of them?
Depends on the day. Tomorrow I'm 5, 7. Next 2 days in 5/7.
Okay, so we won't be able to use this, but we may need it first.
Okay.
Okay?
Go ahead, go ahead.
Yeah.
Can I go to the bathroom?
Yep. Actually, well, girls, if you want, I was gonna say, girls, if you want, my advice. Okay?
Like, get it done or just grab it?
No, get it done, turn it over to me.
Oh, I do actually.
That's it. I covered.
Guys, grab your assessment, please. I think there's 5 or 6 of them on it. Your stuff, they're all freshman out. Stuff, so not from this year. Get your answers down. You can turn it over, please, when you're done. Make sure all your stuff is on the ground. You can use your calculator if it'll help you. Sure, for what? Oh, you're ready. So do me a favor, shoot me an email. I'm gonna send you a form back. I'll caution you now.
Are you already doing something?
No. What I'm saying is, when you fill that form out, call your schools to find out what they want.
Okay.
If they want, and highlight that in the letter, tell me the characteristics. Like if they want leadership in A, B, and C, tell me how, and versus people, shh, excuse me, maybe we don't have enough to do. Maybe we should go. No, but, go and tell me if they want leadership, we'll highlight leadership. If they want cooperative, if they want your community service, we'll highlight community service. If they want initiative, tell me about it. Just tell me, give me an outline of what you want to say. No, but I don't want it to be guesswork, and it may be different for each school, so check. You'd be shocked. The more competitive the schools are, at least from the conversations, we were talking, maybe we had a couple of Yale's, Harvard's a couple of years ago, they want not you to be smart, they want you to see you can look. So the letters that I wrote for those kids were completely different than the other ones. Okay?
Thank you.
Yeah. So just shoot me an
I will.
email. Great.